cloud. Okay. Yes, let me get you this. So today's lesson is on inscribed angles. That is what we are going to be working on. So we're going to look at the relationship of the arc to the angle and the angle to the arc. This relationship is slightly more complex, but I couldn't get a relationship much simpler than central angle is equal to the arc it creates. So let's start if I know the angle. Let's say we know this was 40 degrees. If I'm going to the arc, I want to double it to get 80 degrees. So if we know the inscribed angle, we double it to get the arc. So the arc is twice the angle. So let's say here we're going in reverse. Let's pretend that this is 160. If going from the angle to the arc, we multiply by 2, going from the arc to the angle, what do you think we're going to do? Divide by 2. So 160 divided by 2 would tell me that that inscribed angle is 80 degrees. So if we know the arc, I wrote when double. I should say we double. Whoop, too big on the eraser. So if we know the arc, we divide by 2 to get the inscribed angle. Somebody is out right now. Tyre's out right now when he gets back. So that's our big idea here. Again, I know it's one of those things, it's not like, oh, all we're doing is multiplying and dividing by 2. We'll get problems that are a little more complex than that. Any questions on this initial idea? Okay, let's look at it in action here. Yes. I do not have any napkins. So here with this, if I know this angle is 20, what would I do to get this arc over here? Times 2. 20 times 2 is? Perfect. If I know this arc up here is 80, what am I going to do to find this angle? Yep, I'm going to divide by 2. That gives me now 40 degrees. Okay, 2 pretty easy examples there. This one's getting slightly more complicated, or at least so it looks. The end, I want this arc right here, what I notice is I actually do have this angle, right? So since I had that angle, what should I be doing here? At the angle, I'm looking for this arc. Yep, 42 times 2. And that gives me 84. Okay. Take a look at this one. This one's a little more complicated. I'm looking for this arc, but do I know this angle right here? No, I don't know that right now. That's what we're going to need to figure out. Now, the shape I have is a triangle, right? What do all the angles in a triangle add up to? All the angles in a triangle add up to what? Does anybody remember? They all add up to 180. So since they add up to 180, I know this is 49 and this is 70. So what I'm going to do is start with saying 180 minus 49. So let's just quickly put that in. 180 minus 49 minus 70. And that gives me 61 degrees. So now I know this is 61. Now that I know it's 61, what would I do to get to the arc here? Yeah, we're going to multiply by 2. 61 times 2 gives me 122. So I know that was going to be 122. Alternative way you could have done this, you could have doubled 70, gotten this is 140. Doubled 49, gotten this is 98. You do 360. We'll actually quickly do that on Desmos. 360 minus, I said what, 140 for doubling 70 and 98 for doubling 49. Once we subtract those two from 360, we get 122. Same idea, right? We got the same answer. We used similar ideas. It just looked a little different. That's what I'm saying about these being like a puzzle. You know, you just kind of have to piece together which way to go. Not everyone, it's like, oh, just start here and here. It's go where you start seeing it. Okay, this one got written a little ugly, but here with this says 31x plus 3 is equal to 190, or sorry, the arc's 192. So this arc here is double this angle, right? So if I went from here to here, I'd have to do like times 2. So that's what I'm going to do. I'm going to do 2 times the angle equals 192. So what would I do first to solve this? 2 times 31 and 2 times 3. We could actually divide here. If you wanted to divide instead of distribute, we get 31x is equal to, so that divided by 2, 86. But we'll do a little more traditional, how we've been doing it, distribute here. That's going to give me 62 plus 6 is equal to 192. Now what will we do to solve? Yep, let's subtract 6. And we get 62 is equal, or 62x is equal to 168. Now let's divide by 62. Divide by 62. My gut's telling me this is x equals 3. Well, hey, we got a calculator. Let's confirm it. That was 186 divided by 62. And yep, that is x equals 3. Now, very quickly, Almudas here said, let's divide by 2. If we had done that, that would have given us 31x plus 3 equals 86. Subtract 3 from both sides. We'll get 31x is equal to, wait, I divided that wrong, didn't I? Good. I think I divided wrong there. Let me double check. 192 divided by 2. Well, way too much there. 192 divided by 2. I did divide wrong. It's 96, not 86. Subtract 3, and we'll get 31x equals 93. Then we would divide by 31. And that gives me x is equal to 3 as well. So you weren't wrong. I just say usually we distribute there. So I went with what we usually do. Other way you could look at it to get this problem too is because if I'm going backwards to the angle, that would be a divide by 2 scenario as well, right? So that lines up right with what you were saying with divided by 2. So you weren't wrong or off or anything like that, just a little different way to approach it. Still get the right answer because your logic was sound. Any questions on these? Look, these are going to take practice. They're going to, again, I look at these like puzzles. I can't approach a puzzle the same way every single time. There are certain things I look for, like, oh, I'm going to see if I have like semicircles or I had triangles, stuff like that. Like, you know, I'm looking for certain bits and pieces that are usually there, but it's not always, oh, we start at the same spot every time. So that is what I have for the notes on inscribed angles. I'm going to stop recording. Come on.